Okay, let us solve this worksheet that I prepared for you. The first question says, let one root of this quadratic equation ax square plus bx plus c equals 0, where a, b, c are integers, b 3 plus root 5, then the other root is. See, the answer is very simple, that it will be the conjugate root, that is 3 minus root 5. Only you need to change the sign of irrational part, right? Sign of irrational part. Now, this was a very simple question, but I took this question intentionally in this worksheet because I wanted to tell you once again that it is mentioned in this question that a, b, c are integers. Okay, if it is not mentioned that a, b, c are integers or rational numbers, then we cannot say that the other root is 3 minus root 5 simply, right? Until and unless this is mentioned here, we could not have said this directly, right? I have talked about it in the lectures, so if you are uncomfortable with this idea, then go to the lectures first. So the answer to this question here is option A. Okay, let us look at the next one. The roots of given equation p minus q x square plus q minus r x plus r minus p is equal to 0 r. Again, these kind of questions we have already solved. If you look at the coefficients, these are in cyclic pattern. What do I mean? That if you write it like this, p, q, r, then these coefficients are in the form p minus q, q minus r minus p. What happens is, if you add these coefficients, p minus q plus q minus r plus r minus p, these will get cancelled out and will give you 0. So sum of the coefficients in this case is 0. So we can directly say that one of the roots is 1. One of the roots is 1. This is something that we have discussed already. And in this question, in this particular question, in every option you have got 1 as one of the roots. So, but I told you this just to revise it, right? So if 1 is one of the roots, then what can you say about product of roots? Product of roots, let us say the other root is alpha. So 1 into alpha will be equal to r minus p divided by coefficient of x square, that is p minus q, right? So if you ignore this one, you know the other root is nothing but the product of roots, that is r minus p divided by p minus q. So the option C is the correct option. Okay, all right. If a root of the equation x square plus px plus 12 is 4, while the roots of the equation x square plus px plus q equal to 0 are same, that means if one of the roots of this equation is alpha, then the other root is also alpha. And we know what will be the value of these roots, minus b by 2a, that is minus p by 2, right? Each of these roots is equal to negative p by 2. We already know this from our theory lectures. Okay, now see, if a root of the equation, that is this equation, is 4, okay, one of the roots is 4, so what you can do is you can replace 4 in this equation, right, in place of x, and get the value of p. Okay, once you get the value of p, you will directly get the value of q, because q is nothing but product of these roots. Product of these roots means value of q will be nothing but p square by 4. So once you obtain p, then you just place p here, value of p here, and you will get value of q. Okay, so let us put 4 here. 4 squared plus 4 into p plus 12 equals 0. So this is 16 plus 12, 28. So p will be negative 7. Okay, now simply q is nothing but negative 7 squared, that is 49, divided by 4. Option C is the correct option. All right, let's move to the next one. If alpha and beta are the roots of equation x square plus x plus 1 equals 0, then equation whose roots are alpha raised to power 19, beta raised to power 7. Now this is a question which can be solved using complex numbers, but we are solving it at our class 10th level. So let us think about this question like this. If I see this expression x square plus x plus 1, okay, I get an idea about this x cube minus 1. What is x cube minus 1? X cube minus 1 is nothing but x minus 1 into x square plus x plus 1. Right? You remember this? If you know this expression, x cube minus 1 is nothing but x minus 1 into x square plus x plus 1. So whenever you see this kind of expression, x square plus x plus 1, you can do this manipulation that you multiply it with this and put it equal to x cube minus 1. Now if this is equal to 0, so this entire expression will be equal to 0, right? This is mathematically possible. Whatever I am doing is very much possible. Now see, alpha and beta are the roots of this equation, right? That means alpha will satisfy this also, right? Because what do you mean by alpha being the root of this equation? That if I put x equal to alpha, this expression will become 0, right? So if I put x equal to alpha in this entire expression will again become 0. So that means I can put x equal to alpha here also. So that means alpha cube minus 1 is also equal to 0. Hence I can say alpha cube is equal to 1. And there is nothing special about this root alpha. Beta will also follow the same pattern. So I can simply say that beta cubed is also equal to 1, right? Because you could have written this expression here with beta cube minus 1 equal to 0. Okay, so alpha cube is equal to 1, beta cube is equal to 1. So what can I say about alpha raised to power 19? That it is equal to alpha raised to power 18 into alpha. And what is alpha raised to power 18? It is nothing but alpha cubed raised to power 6 into alpha. Now this is 1, so 1 raised to power 6 is 1. So alpha raised to power 19 is nothing but alpha. And similarly, you can manipulate this beta raised to power 7. This is nothing but beta raised to power 6 into beta. And what is beta raised to power 6? If beta cubed is 1, then beta raised to power 6 is also 1. So beta raised to power 7 is equal to beta. So these roots are nothing but alpha and beta. So the equation whose roots are alpha raised to power 19, comma beta raised to power 7 will be the same equation as this one, right? So the answer option is option, which is the right option? This is not the right option. This one is the right option, option D, because the equation will also remain the same, right? So this was about this question. Let us look at the next one. If x1, x2, x3 are distinct roots of the equation ax square plus bx plus c equal to 0, then now we know that this equation here has got highest power of x as 2, so it can have maximum 2 roots, right? Maximum 2 distinct roots. Now see, if it can have maximum 2 roots, but it is given in the question that x1, x2, x3 are distinct roots of this equation. This is possible only when a is equal to b is equal to c is equal to 0. That is, this is an identity, right? It will be satisfied on any value of x, right? So a is equal to b equal to c equal to 0 is the right answer for this question, and we have discussed about this in our lectures also, right? So whenever you see that there are more than 2 solutions or more than 2 roots of an equation looking like a quadratic equation or having highest power of variable as 2, then you can simply say that it is an identity and all the coefficients are 0, right? Okay, so let us discuss next set of questions in the next video. Okay.